See, we have a 400 centimeter long horn. 400 centimeters there in blue. And in red, that's the distance from the mouth exit to the motor side of the driver. And the little blue there is the distance from the beginning of the horn, the throat side, to the front of the cone. And those are zeroed out, so they're at the very, very end and the very, very beginning of the horn. But we're gonna move the motor side up in there. See what's happening? And look what's happening here. And when you get farther and farther in there, like notice, I'm like 1/4 of the way in here, and I'm hitting the 4 times 1/4 wavelength here. That was formerly a cancellation notch, but I've moved the driver up in there so far, about 300 centimeters and 100 centimeters. So that's about 1/4 of the length up in the horn, and it's filling in the 4 times 1/4 or the full wavelength frequency notch, where the front of the driver's output was going across the back of the driver's output, and we're totally out of phase, or quite a bit out of phase. But since it's a horn shape, the horn's doing a little bit. But when you move the driver way in there, you make another resonator. It's in the horn, so it's kind of disguised in the shape, but you're making a second resonator, or you're making a series tuned, more and more of the series tuning. So the second half after the driver is creating a different scenario. But also, since the front and the rear of the driver are now so much closer together, the fundamental goes nuts. This resonance is kind of like what it was. This fills in, but this gets saggy as heck. And then look at the electrical impedance. This is the real story. Look at what's happened to this. The impedance spike has shifted over. Here's a little bit of pressure from the fundamental resonance. Here's a whole lot of presence from all that stuff going up. Because of where the other side of the driver is in the horn, look at what it's doing. This shit's weird.